Good afternoon to everyone. I'm Laveena Sehgal from IT Department, IIMT College of Engineering, going to represent topic Introduction of Stack. So before starting this topic, I would like to tell you about what is data structure. So what is data? Anything which gives us information about anything is called our data. If I talk about student, their roll number, their name, their address, their branch, their email ID, their account number, it's all information tells us about data of particular student. Similarly, if I talk about employee, and employee ID, employee email address, employee salary, employee address. These are the all parameters there which tells us about data or information of a particular employee. So what next comes to the structure. Structure is basically tells us how we can represent our data either in the form of graph, either in the form of tableau, either in the form of average, either in the form of stacks or queues. So data structure is equals to data plus structure, which is a combination of data and structure. So data structure, we can say that how we can organize or store our data in such a way so that it can be used efficiently for further use. So next comes to the topic, our topic, that is tags. Basically, I will tell you that data structure is of two types. One is primitive data structure and another one is non-primitive data structure. So primitive data structure is that data structure in which data types are already built in, and non-primitive data structure in which we are creating our own data types according to user use. So first is a stack is a non-primitive linear data structure. It is an ordered list in which addition of new data item and deletion of already existing data item done from only one end, that is top of the stack. It means if I want to add new element or insert new element in a particular stack or in a particular list out, so it should be done only from one end, that is top of the stack. We can't add an element from another end. Only one end we can add element or insert element, or if we want remove from that element, that stack, or if we want to delete particular element from that stack, it should be done only at the top of the stack. As all deletion and insertion in a stack is done at the top of the stack, or last added element will be first to be removed from the stack. So it is called last in first out. It means that if we delete or insert element at the top of the stack, means we are adding at the last and removing from the last, first in first out, adding last and take it out from the first one. So that is why stack is also called last in first out, LIFO. So example comes, a common model of a stack is the plates in a marriage party. Fresh plates are pushed onto the stack and popped off the stack. If you have already seen in your marriage parties, there is a stack of plates. You are taken out from the last or inserting it at the end. Means pushed onto the tab or pop up to the tab. Similarly, if I talk about biscuits, you are taking from the one end, removing the wrapper and closing the biscuit from one end only itself. So adding biscuit or removing one biscuit from a packet, it will be done only from the one end. Next, whenever stack is created, the stack base remains fixed. As a new element is added to the stack from the top goes increasing. When we adding a particular element in the stack, then value of top will be increased. If I remove from the stack, then value of top will be decreased. Conversely, as the topmost elements of the stack is moved from the stack, then value of top will be decrementing, means decreasing. As I can show in the next slide, with the help of example, how the value of top is increasing and decreasing. So here you can see the example. Initially stack is empty. So value of when stack is empty, the value of it means there is no element in the stack. So value of the top will be -1. If I insert one element at zeroth place, the value of top will become 0. And if add one more element at one place, so value of top will be increased from 0 to 1. Now, if stack top decreasing during deletion, there are two elements in the stack. If I remove or delete a first element from first place, the value of top will be decreased by 1 from top 1 to top 0. If I delete another element, that is 10, which is at 0th place, then stack will become empty and value of top will become -1. Stack can be implemented in two ways, static implementation and dynamic implementation. Static implementation of stack uses arrays to create stack. So it is a very basically simple technique which is not a flexible way of creation as the size of stack has to be declared during program design. After that the size cannot be varied. It means in stack implementation the size of the stack is fixed. Like you can check out in your shoe rack or Elviria racks or in library you can check out your racks for storing books and all. The size of that racks is always fixed. It's we can't increase or decrease that racks. When we are creating static implementation of stack, we have to mention the size of the stack which is fixed, which is not be a flexible. We can't change it again and again. So static implementation is difficult, which and it is not flexible also because it's a wastage of memory also because I have a three racks suppose and I have to store only two books. The rest space is not useful for us. Similarly, if I have two shoes in a rack and I don't require three racks or three rack mirror for that. So memory space is waste for that. If I had more books rather than the size of the rack, so that will be difficult for me to storing and organizing that books in a rack. Moreover, static implementation is not too efficient with respect to memory utilization. So, as a declaration of arrays done before the start of the operation, now if there are too few elements to be stored in the stack, the statically allocated memory will be wasted, as I have already told you. On the other hand, if the number of elements to be stored in the stack, then we can't able to change the size of array to increase the capacity. Similarly, if I have more than books according to the size of the rack, so it will be difficult for me to store that books because I have no capacity for storing that book. Dynamic implementation is always very good and it is called linked list implementation and use pointers to implement the stack type of data structure. For example, in a train, it is a combination of boxes which comes in a chain form. So I can add boxes or I can delete from that boxes from the train itself. It is a form of linked list. So we can increase either the size of data structure or we can decrease the size of data structure. It is a hand. So now next comes on the topic operations on stack. The basic operations that can be performed on stack are as follows. First is push. When we are adding some new element on the top of the stack, means we are pushing some plate on the stack of the plates, or we are adding some element on the stack of the um, on the stack. So we call that push operator. Means we are inserting particular new element on that. When new element is inserted at the top after every push operation, that top is incremented by 1. Means value of incremented will be 1. As I've already discussed in previous example, that value of top will be incremented from 0 to 1. In case the array is full, if the array is full and no element is accommodated, means we can't add or insert any element further, then stack is comes under full condition and it is called that overflow condition. Pop. The process of deleting an element from the top of the stack is called pop operation. If I am deleting or removing some element from the stack at the top of the stack or it is called pop operation means I am extracting element from the stack. I'm going to remove that element from the top of the stack. So when I'm going to remove, then value of top will be decremented by one. So as I've already discussed in previous examples also, that value of stack is decremented from 2 to 1 and 1 to 0. When stack becomes empty, then value of top becomes -1 and it is called stack underflow condition. So the process of deleting an element from the top of the stack is called pop operation. After every pop operation, the stack is decremented by 1. If there is no element on the stack and the pop operation is performed, then this will be result into stack underflow condition. Now next operation on stack will be done is P. If one is interested only about an information stored at some location in a stack, then PEEP operation is required. It means if I want to extract some element in the middle of the stack or want to remove at a particular position, then we use PEEP operation. If next operation is update. If I want to update any information of a particular student or particular employee, then we use command update operation is required when the content of some location in a stack is to be changed. So next comes to the stack terminology, means what terms we are using for representing the stack. First is max size. It tells about the maximum size of the stack. The term is not standard one. We use this term to refer the maximum size of stack. Next is top. This term refers to the top of the stack. The stack top is used to check whether stack is under overflow condition or underflow condition. When we can't add another element further in a stack, that is overflow condition of the stack. When stack is empty, it means stack is in underflow condition. And initially top store -1. Initially value of store is always -1. This assumption is taken so that whenever an element is added onto the stack, the top is first incremented and then the item is inserted into the location currently indicated by the top. Means initially the value of all stack is always -1. It is incremented from -1 to 0 to 1 1 to 2 and further till the end of the size of the stack. So next comes to the stack terminology, stack underflow. As we already discussed about underflow and overflow. So underflow condition is the situation where the stack contains no element, means it is empty. At this point, the stack of the top of the stack is represented at the bottom of the stack. Stack overflow is the condition or situation when the stack becomes full and no more other elements can be pushed onto the stack. In this point, the stack top is present at the highest location of the stack. Now, next comes to the point applications of stack. There are various applications of stack. First is recursion. Recursion is an important facility given by the programming languages such as Pascal, C, etc. Sometimes machines are also known as which use built-in stack hardware called stack machine. So how stacks can be represented by using Polish notation means we represent our stack by the help of Polish notation mathematically. So first I will tell you what is recursion, which is a name gives to a technique which defines a function in terms of itself. Means when we say that function call by itself, so that is the term defines recursion. A function which call by itself, thus the chain of process occurs. There are two important conditions that must be satisfied by any recursive procedure. These are the two conditions which recursion follows. Each time a procedure calls itself, it must be a near in some sense solution. There must be a decision criteria for stopping the process or consumption. So there are some important popular implementation of recursive computation. First is calculation of factorial value, quicksort, proper of Hanoi problem. These are the further implementation of recursive or recursion. First example, very simple example of recursion is calculating factorial value of an integer. For example, n factorial will be calculated by n into n minus 1 into n minus 2 into up to so on till the 1. Means if I want to calculate 5 factorial means 5 into 4 into 3 into 2 into 1. So this is the simple basic program for recursion. How we can calculate or implement simple factorial function. Fact equals to 1 for we will apply for loop starting from I equals to 1 till n. Do then we apply method of factorial which is equals to I into fact till the end of integer. And for return fact means we are using recursive function here. So how recursive defines for the same, if n equals to 0 means our number start from 0, fact equals to 1, else अगर number if number in n equals to 0 or fact equals to 1, otherwise f factorial equals to n factorial n minus 1 means integers, for example 5 into factorial n minus 1, 4 into 3 into 2 into 1 till the end, and if return factorial stop. This recursive definition to implement using stack show in Word file. Now another problem, Tower of Hanoi problem. Another complex recursive problem is the Tower of Hanoi problem. This problem has a historical basis in the ritual of ancient Venetia. The problem can be described as follows. Suppose there are three pillars A, B and C, and each pillar containing n discs of decreasing sizes so that no two discs are of the same size. Means we have three pillars which has size n, and we have to move this from one pillar to another pillar. Initially all discs are stacked on a pillar in their decreasing order of size, because if we are removing disc from one pillar and adding to the other. Another example is Tower of Hanoi problem, which is another recursive problem is the Tower of Hanoi problem. The problem has the historical basis in the ritual of ancient Venetia, which can be described as follows. We have three pillars of disc A, B, C. There are n discs of decreasing size so that no two discs are of the same size. Initially, all the discs are stacked on one pillar in their decreasing order of size. So next comes to Tower of Hanoi problem. It means we have three pillars A, B, and C. So we have to remove one disk from one pillar and move on to the another. So let us the pillar be A, which contain another two pillars are empty. The problem is to move all disks from one pillar to another using an auxiliary so that only one disk may be moved at a time. A disk may be moved from any pillar at a time to another. At no time can longer disk be placed on a smaller disk. So this is an example how move the disk from one place to one pillar to another pillar. The solution of this problem is move n disk from pillar A to C, while the pillar B means move first n minus one disk from pillar A to B, then A to C and B to C. The problem implementation is this one.